Okay, so for this example, we're told that a man moves vertically up an object with a mass of 5 kilograms and a distance of 2 meters with a constant speed. So automatically we can see that the velocity is a constant, and this tells us that the acceleration is going to be 0, right? And when the acceleration is 0, we know for sure that the change in kinetic energy is also going to be 0. And since we know that the change in kinetic energy is equal to the net work, then that should be 0 too. You can see right here, right? So the part A asks what is the total amount of work. It's gonna have to be 0, right? Because the acceleration is 0 and the change in kinetic energy is 0, right? So how can we show this with a bit more detail? Here we have the object, right? We have the force being applied by the man, and we have the actual weight, right? And I expanded these and showed these out, right? So here we have the force that's pulling up the object, right? The work that's being pulled up, and that's equal to mg y2 minus y1, right? And this has to be a positive in here, right? And this, since this will be positive, because the velocity is going to be a constant velocity, so we know that the final is going to be more than the initial, right? And so that's why we get that. So this will be positive. And with this, we know that this whole entire thing is then going to be positive. It's going to be greater than 0. Now for the weight, the work going downwards, this has to be a negative mg because it's less than 0, right? So this whole thing is going to be negative, right? Because we know this part's positive, right? So they should be of the same magnitude, but they're just opposite of each other. They're in opposite directions. So we see here that the work going up plus the work going down is going to be equal to 0. Now how would that look like here in this problem? It's going to be negative mg y minus y2 plus mg y minus y2 is going to be equal to 0, because this is representative of the work going up, and this is this is representative of the work going down, and this is representative of the work going up, right? And since they're the same magnitude per se, they're the same value, but just opposite directions, they're going to cancel each other out, and the work is going to be 0. Right, now for part B, it says what is the work done by the man. Now the work done by the man is the applied force going up is represented right here, right? This is the work done by the man, mg y2 minus y1. And the part C, it says the work done by the weight. Well, that's the work going down, and that's negative mg y2 minus y1, which is the negative value, right? And that's it.